Hello, welcome to another lecture video discussion. In this discussion, we will be introducing you to continuous probability distribution. In our previous discussion, we looked at chapter 5 of the lecture note, which is on random variables. We talked about random variables as any variable that takes random values as a result of a random experiment. We said there are two types of random variables: discrete random variables and continuous random variables. In our previous chapter, we discussed some examples of discrete random variables and examples of continuous random variables. We also spent some time to look at some probability distributions used to describe discrete random variables. We talked about discrete uniform probability distribution, binomial probability distribution, Poisson probability distribution, and hypergeometric probability distribution. In this video, we will be looking at continuous probability distributions. Basically, we are going to look at three probability distributions used to describe continuous random variables. We will start with continuous uniform probability distribution, and then we'll look at normal distributions and end our discussion with exponential distribution. Just so you know, chapter 6 is very important for your second midterm test. And so let's spend some time and look at all these probability distributions. But the most important thing is, for every probability distribution we will be looking at, we are going to look at how to calculate the probability of a value of x. We will also look at how to calculate the mean, and then we'll spend some time on how to calculate the variance and the standard deviation. So this is no different from what we did with discrete random variables. We're gonna do the exact same thing. We look at how to find the probability for that probability distribution, how to find the mean, and how to find the variance. Let's start with a little bit recap on what continuous probability distributions are. So when we discussed random variables in the previous chapter, we said a random variable could be either discrete or continuous. We were able to discuss the difference between discrete and continuous random variable. As a reminder, please note that continuous random variables basically can assume any value within an interval of numbers. Unlike discrete random variables that take whole number values, continuous random variables could take decimal values. We were able to discuss some examples of variables that are considered to be discrete, like age in years, number of cars, number of pets, number of credit cards. And if you consider all these examples, you will know that if I ask, as a researcher, if I ask my participant to give me, for example, number of shoes, they are going to give you whole numbers. Continuous random variables, on the other hand, are those that do not take whole numbers. And so we say one difference between discrete random variables and continuous random variables is that for discrete random variables, we obtain the values by counting. But continuous random variable values are obtained by measurement. Now, instead of just looking at the examples of discrete and continuous random variable, let's spend some time in this video to talk about the probability of continuous random variables. How do we obtain the probability for different continuous random variable? The first one we'll be looking at is uniform probability distribution. Now, if you take a look at the diagrams here, you will notice that for each of these probability distributions, we obtain the probability values by measuring the area under the graph. And so for uniform probability distribution, we measure the area within an interval of numbers, say x1 and x2, and our concentration is what is the area here. For normal distributions that are symmetrical, we look at the area between two numbers, x1 and x2. Then for exponential distribution, you will do the exact same thing. And this is why we consider these probability distributions as continuous probability distributions. We are not looking at distinct values. We are looking at the measurement between two values. And that is what makes continuous random variables different from discrete random variables. Okay, so let's start with the first continuous random variable probability distribution. And this is called the continuous uniform probability distribution. Know that this is different from discrete uniform probability distribution, which was discussed in the previous chapter. Here we are looking at the probability of a specific value being observed within an interval of time. And so we say a random variable is considered to be uniformly distributed as a continuous random variable whenever the probability is proportional to the interval length. The probability density function for a continuous random variable is what we see here, but this is not a formula we use to calculate the probability of a continuous uniform probability distribution. To find the probability of a continuous uniform probability distribution, we use the uniform probability distribution function. Note the difference. This is the density function. This is the distribution function. This is how we calculate the probability for a uniform probability distribution considered to be continuous. And so we take a look at an interval of time, and then we look at the probability that we will observe an event occurring within that big interval of time. Let's look at some examples on how we calculate the probability for a uniform probability distribution. Let's say later customers are charged for the amount of salad they take. Sampling suggests that the amount of salad taken is uniformly distributed. Right, so that tells you the kind of distribution we're looking at. It's a uniform probability distribution, which means it looks something like this. But it's uniformly distributed between 5 ounces and 15 ounces, which means our distribution starts from an interval of A, which is 5 ounce, to the end of that interval B, which is 15 ounce. So our uniform distribution here starts from a small value of 5 and it goes all the way to a bigger value of 15. This is where it ends. Now we're trying to find the probability that a customer would take between 12 and 15 ounces. And so our probability is to find the chances that somebody who comes to the restaurant would take between 12 and 15. So the distance between the 12 and the 15 is our x. Now to find the probability for this, we said the probability distribution function f of x is equal to the interval of x between divided by the distance from A to B, which is B minus A. Now, if we are trying to find the area for this uniform probability distribution between 12 and 15, then our x is the distance between 15 minus 12 divided by the bigger value B, which is 15, minus the smaller value A, which is 5. And so in this case, we want to know the probability that somebody will take between 12 and 15, given that the interval is from A, which is 5, to 15. So here we are measuring 3 over 5. 15 minus 5, that will be 10. And that will be equal to 0.3. I mean, it's going to be 333 repeating. But what we're looking at is there is a 30% chance, 33.3% chance that somebody will take between 12 and 15 ounces if the interval is from 5 to 15. So the area under the curve here is the area 0.333. And that is what has been solved here. We are looking at the value of x between the 12 and 15, given that we have an interval from 5 to 15. So this is how we calculate the probability for a continuous uniform probability distribution. Now the next thing is, how do we find the mean? Like we did in the previous chapter, in each case, we're going to look at how we calculate the probability for the given probability distribution and how we find the average and the variance as well. Now, to calculate the average is just an addition of the smallest value in the interval and the biggest value in the interval divided by 2. The variance is calculated by subtracting the smallest value in the interval from the big value, or squared, divided by 12. Let's take a look at an example on how to calculate the mean and the variance of a continuous uniform probability distribution. So Celadus customers are charged, and this is going back to the same story. Celadus customers are charged for the amount of salad they take. Sampling suggests that the amount of salad taken is uniformly distributed between 5 ounces and 15 ounces. What is the expected value and the variance? Now, whenever we say expected value, we are also referring to the mean. So let's calculate the expected value, which is the mean, and let's also calculate the variance. Now, remember our formula said our mean is equal to the smallest value in the interval plus the bigger value in the interval divided by 2. From the question, it says it's uniformly distributed between the smallest value of 5 ounce and the bigger value of 15 ounce. So we're looking at 5 plus a 15 divided by 2. Now that gives us 20 at the top here divided by 2, and 20 divided by 2 is 10. And so the average ounce of salad they take is 10 ounces. But to calculate the variance, we look at the difference between, so our variance is equal to the bigger value minus the smaller value, all squared, divided by 12. Now somebody will say, why are we dividing by 12? Okay, so to prove the variance, there's a formula for that, but that is beyond the scope of this course, and so I'm not going to argue with that. But our variance will be equal to the bigger value based on the question of 15 ounce minus the smaller value of 5 all squared divided by 12. So we're looking at 15 minus 5, that is going to be 10 squared divided by 12. And 10 squared we know is 100 divided by 12, and that will give us 8.3. So this is how we calculate the mean and the variance for a uniform probability distribution. If we want to find a standard deviation, how do we do that? How do we calculate the standard deviation of a random variable considered to be continuous if we already know the variance? Remember, we said the standard deviation is equal to square root of the variance. And so if we know the variance to be 8.33, then our standard deviation will be equal to square root of 8.33. And that is how we find the standard deviation. Now, it's important to understand that all kinds of continuous random variables where we have an interval between a smaller value and a bigger value, and our goal is to search for the probability of something occurring within that interval, is what we describe as a continuous uniform probability distribution. Let's take a look at a practice question here. I would like you to spend some time on this practice question. When we meet again in class to discuss or to look at this chapter again, I will ask you what your answer was. But suppose in a quiz there are 30 participants, the question is given to all 30 participants, and the time allowed is to answer it in 25 seconds. So it follows a uniform probability distribution where we start from 0 to 25 seconds. Find the probability that a participant responds within the first 6 seconds. So the interval is from 0 to 25. Okay, not a perfect line. Okay, I think I can do better than that. Okay, so the interval is from 0 to 25. And we want to find the probability that somebody will answer within the first 6 seconds. So this is the area that we're looking for. Use the formula to find that probability and then find the expected value and the variance. Now the next one I would like us to look at is the normal probability distribution. Normal probability distribution is known to be the most popular and important probability distribution because it's applied in a wide variety of scenarios. If we want to know the height of people, it follows normal distribution. Let's say we take a test and we want to know the distribution of the test scores, it follows a normal distribution. Weight is normal distribution. Amount of rainfall is normal distribution. Distance to your favorite restaurant, it follows normal distribution. So this distribution is very popular. It was introduced in 1973 by a French mathematician called Abraham Demov. And he derived this whole normal distribution. Now, any kind of distribution that looks like this, where we see a symmetry between two halves of the distribution when we split it into two equal parts, follows a normal distribution. Age, in terms of years and month, could be normal distribution. Weight follows normal distribution. Income follows normal distribution. There are so many instances where we see normal probability distribution, and we are going to look at how to calculate probability for normal distribution. The probability distribution function for a normal distribution is this, but that is not what we are going to use to find probability for normal distribution. Okay, I'm going to say it again. Very important. This is not a formula we will be using to find normal probability distribution. And so please, on the test, do not quote this formula. This formula is just to show you that for normal probability distribution, we already have the mean and we already have the standard deviation. So the good news is we will not be calculating the mean and standard deviation in this case, because to calculate the probability distribution, the function of a normal distribution, we already have the mean and the standard deviation. They describe what the normal distribution is. But if for some reason, if we want to calculate the mean and normal standard deviation of a normal distribution, we've already done that. The mean is where we add all the numbers and divide by the total number of observations. So we already did that. There's no need to do that here now. What we are going to focus on with normal distribution is how to find the probability for normal distribution. Now, like I said earlier, normal distributions are described by the mean and the standard deviation. But somebody would say on a normal distribution curve, what is the mean telling us and what is the standard deviation telling us? The mean can be any number. It can be a negative number, it can be a positive number, it can even be a 0. But the mean tells us the position of the center of the curve. Let me give you an example. Let's say I have an x and y axis like this. If the mean is at 5, let's say the mean is equal to 5 for normal distribution, that is where the center of the curve is. That's where we see the center of the curve. If the mean increases and the mean is like, say, maybe 20, that means the curve moves on the right to the right of the x-axis, and the mean now is increased to 20. If the mean is, say, 40, that is where the center is, and that tells us that the curve has moved to the right. So the mean tells us the position of the curve. Now, the standard deviation, on the other hand, determines the width of the curve. When the standard deviation is large, it tells us that the width is also going to be large. When the standard deviation is small, it tells us that we are going to see a very slim curve. So take a look at this. When the standard deviation is 15, we have a very tall but also very thin curve. When the standard deviation is increased to 25, the curve is short but flatter. And so the standard deviation tells us if it's going to be thinner and tall, or it's going to be short and flat. This is when you have small standard deviation, and this is when you have a huge or a big standard deviation. So that is what those two parameters basically represent whenever we create the curve. Okay, I'm not going to ask you to ever create the curve, but it's good to understand that the mean shows you the position of the curve. The standard deviation shows you how wide or slimmer the curve is going to be. Now, all normal distribution curves are like this. They are very symmetrical, which means if we divide them into two equal parts, this side here is going to look very similar to that side. And so the whole area under the curve is equal to 1. If we divide it into 2, this side will be 0.5, the other side will be 0.5. Now, alternatively, the whole area is 100%. If we divide it into 2, this side will be 50%, this side will be 50%. And so using the empirical rule, and we'll talk about the empirical rule later, don't worry about it, but we see that it's very symmetrical and the two sides are mirror images of the other. Okay, now let's focus our attention on how to calculate the probability for a normal distribution. How do we calculate the probability for a normal distribution? We don't use that complicated formula. No, that is not how we calculate the probability. What we use is what we call the standard normal probability distribution table. You see, normal distribution comes in two parts. So a normal distribution could be either a standard normal distribution or a non-standard normal distribution. This is non-standard. A standard normal distribution has a mean equal to 0 and a standard deviation equal to 1. When it is non-standard, the mean is not equal to 0, the standard deviation is not equal to 1. And so let's say we have a normal distribution that has a mean of say 20 and a standard deviation of say 5. That is a non-standard normal distribution, right? Now, the interesting thing is, to find the probability for a normal distribution, we have to convert a non-standard normal distribution into a standard normal distribution. And then after that, we will use the standard normal table to find the probability. And so we don't use that complicated formula that I showed you. We don't use it. What we do is we use a very simple formula to change non-standard into standard, and then the next step will be to use the standard normal table. Okay, let's do that exercise quickly and then we'll bring our discussion to a close. So to find the probability for a normal distribution, there are two steps. Step 1, we will use this very simple formula here to convert the non-standard to a standard normal distribution. And then in step 2, we will use the standard normal table to find the probability. Okay, and that's how we'll be doing here. Now let's work on a quick example here, and then I'll show you how we will use this two steps approach here to find the probability, and then we'll bring our discussion, our first part of the discussion, to a close. Okay, so it has been determined that demand during replenished lead time is normally distributed. Now, always look out for stuff like this. If it is uniformly distributed, I will tell you. If it is normally distributed, I will tell you. If it is exponentially distributed, I will tell you. So here we are looking at a normal distribution, which means we are looking at a curve that looks like this. It's normally distributed with a mean of 15 gallons. Like we said, the mean is always at a center, and so we're looking at a center of 15 gallons and a standard deviation of 6 gallons. So our standard deviation is equal to 6. Now, the manager would like to know the probability that demand during lead time will be below 20 gallons. So it's 15 gallons is at the middle. 20 gallons will be a little bit higher than that. And so the manager wants to know what proportion of the demand will be below 20 gallons. The probability less than 20 gallons. So our X here is 20, and we want to find the area under the curve for this. You see, to calculate probability for all normal distribution, we need 3 numbers. We need the mean, which in our example here is 15. We need a standard deviation, which is 6, and we need a value of X, which is 20. So we are going to find a probability that X is less than 20, which means this area under the curve right here. Step 1 says standardize it. Change it from a normal distribution to a standard normal distribution using this formula here. X minus the mean over the standard deviation. And so here we're looking at the value of X, which is 20, minus the mean of 15 divided by the standard deviation of 6. So that will be 5 over 6. And when I divide 5 by 6, I get 0.83. Just like we see over here. But that is just the first step. Okay, this is not the final answer. It's just the standardized value of X. Now we move on to the second and last step, which is to find the area under the curve using 0.83. And that's what I want to show you. So you go on Moodle, and on under chapter 6 of the lecture notes, you will see the standard normal probability distribution table. Okay, and it's not just this it's everywhere. You go on Moodle, you will see this, or you can just download standard normal probability table on Google. But when you open this, it gives you the standard normal probability table. Our value from the calculation, our value of the standardized value was 0.83. So I go on my table, my standard normal probability table, and I'm gonna look at 0.83, and this is how I would do it. Okay, so you look at the 0.8 on the bold font here on the first column. We look up the 0.8, which is right here, and then the 3, which is the second digit after the decimal point from here. And so we had the value of z to be equal to 0.83. The 0.8 on this side, the 3 on that side. Where these two intersect, which is 0.79673, that is the probability we are looking for. And so we look at the intersection between the first 2 digits and then the last digit. 0.8 on this side, the 0.03 on that side. And where they meet, that is the probability we're looking for. So from the table, the area is 0.7967, and that is how we find the probability for a normal distribution. There's another way you can do this if you have the recommended calculator for the course. This is the step that you have to follow. But if you do not have the recommended calculator, this is the approach to finding the area under the curve. We look up 0.8 on this side, the 0.3 on the other side, where they intersect, 0.7967, that is the area we're looking at. Now, the area we're looking at is 0.7967, which is on this side. If I want to look up the other side of it, so this is the 0.83, the standardized value. The 0.7967 is the area we found from the table, which is less than 20 gallons. If I want to find the area above the 20 gallons, I use the complement rule, which is 1 minus 0.7967, and the complement rule will say the area above 20 gallons is 0.2033. There's a practice question here. I want you to look up the exact same thing and we will discuss it when we meet. But here we are looking at the time taken to assemble a car following a normal distribution. Again, it tells us it's normal distribution. If it follows a normal distribution, then we need to know the mean, which it gives us here. The average, which is the mean, is 20 hours, and the standard deviation is 2 hours. Let's find the probability that x, first of all, is less than 19.5, and the probability that x is more than 22 hours. So let's start with the first case. The mean is here at 20. The standard deviation is 2. Let's find the area less than 19.5. And then after that, we'll find more than 22 hours. Try your hands on this. We will meet in class and discuss this as well whenever we have the chance. Okay, so I'm gonna end here and I'll see you in the next video.